Welcome and thank you for standing by. I would like to remind all parties that your lines have been placed on listen only until the question and answer portion of today's conference. At that time, if you're wishing to ask a question, please press star 1 on your touch-tone phone, and please be sure that your telephone is unmuted and clearly record your name at the prompt so that your question may be introduced. Today's conference is being recorded. If you should have any objection, you may disconnect at this time. It is now my pleasure to turn the call over to Ms. Felicia Chow, NASA Communications. Thank you, ma'am. You may begin.
Hi, and thank you all for your patience. I'm Felicia Chow, Public Affairs Officer at NASA headquarters in Washington, D.C. I'd like to welcome you to today's media teleconference, where we will be discussing the most recent Hubble observations of Pluto's moons. We have 5 panelists joining us today. For those watching via Ustream, please note that there will probably be a 30-second delay to the actual telecon. To watch any videos mentioned and for all the graphics the panelists will be using, please go to www.nasa.gov/Hubble. A short briefing, and once finished, we will then move to the question and answer session, accepting questions from media that dialed into the telephone bridge, and those that submitted questions via Twitter using the hashtag AskNASA. This media telecon will be limited to 1 hour. Today's panelists are John Grunsfeld, Associate Administrator for NASA's Science Mission Directorate in Washington; Mark Showalter, Senior Research Scientist at the SETI Institute in Mountain View, California; Douglas Hamilton, Professor of Astronomy at the University of Maryland, College Park; John Spencer, Scientist at Southwest Research Institute in Boulder, Colorado; and Heidi Hamel, Executive Vice President of the Association of Universities for Research in Astronomy in Washington. And with that, let's get started. John Grunsfeld.
Thanks, everybody, for joining. Sorry about the troubles getting started, but we're up on the website now, so hopefully you've navigated to that page. Our job here at NASA is to innovate, explore, discover, and inspire. And in science, we're trying to answer, key scientific questions that are very much human questions about where did we come from, where are we going, and are we alone? Studying the Pluto system as we approach our July 14th encounter with the New Horizons spacecraft passing through the Pluto system, we're already discovering a lot of surprising things about this mysterious system of dwarf planet Pluto and its moons. This system is a relic left over from, we believe, the beginning of the solar systems. And so this is helping us to answer the question of our own origins. Pluto has inspired generations due to its mysterious nature, and now we're beginning to unravel those mysteries using observations from the Hubble Space Telescope. We're exploring a new realm using the Hubble, and as you know, I'm very much a Hubble hugger. This year we're celebrating the 25th anniversary of the Hubble Space Telescope on orbit, and also the 50th anniversary of spacewalking. With the advanced camera for surveys that we installed on STS-109 in 2002, and the incredible wide field camera 3 that we installed on STS-125 in 2009, Hubble is much more powerful today than ever. It's definitely in its prime. This has enabled us to make the observations of Pluto and its moons that will be described today. No ground-based telescope can make these observations. And after the Pluto New Horizons spacecraft flies through the system and gives us up-close and personal views, the upcoming James Webb Space Telescope and Hubble will still be able to follow the story of this enigmatic system. With that, I'd like to hand it over to Mark to describe the discoveries that we're talking about today.
Thanks, John. I really appreciate the invitation to be here today. Doug and I are going to be talking about results of a research project that started literally 4 years ago. I can even tell you the exact date. It was June 28, 2011, that Doug and I obtained our first images of the Pluto system with the Hubble telescope. At the time, we were actually looking for evidence of a faint or dusty ring around Pluto, which, by the way, we didn't find. But what we did find is an extra little dot that was off to the right of Pluto at that time. Later, we confirmed that to be a moon of Pluto, the fourth moon, now called Kerberos. And about a year later, working with a much larger group from the New Horizons team and working with a much bigger allocation of time from the Hubble telescope, we went back to the system with much better observations, and we even detected then the fifth moon, now called Styx. So if you look at Figure 1 here, you see the Pluto system as we know it today. There are Pluto and its very, very large moon Charon in the middle, and then 4 much smaller moons orbiting around the outside. The way you can think of Pluto and Charon is as a kind of a double planet. These other 4 small moons are orbiting 2 objects instead of 1, and that creates all kinds of interesting consequences, which is what we're learning about in this study. The way you can think about it, in fact, is if Pluto and Charon are 2 weights at the end of a dumbbell, 2 very unbalanced weights, by the way, but 2 weights, and that dumbbell is rotating. So in the middle of the system, you have this rotating dumbbell, and the 4 other moons are responding to the gravity fields of both objects, rather than what is much more typical in planetary systems, where there's just one body in the middle of the system. By the way, Nix and Hydra were also discovered in images from the Hubble telescope back in 2005 and 2006. So if we go on now to Figure 2, what you should see is it's actually a movie. This is the discovery of Styx from 2012. What you see here, each of the frames of this movie, there are 3 frames. They are separated by 96 minutes each, and each individual frame is about 30 minutes of total integrating time on the telescope. So they're very, very long exposures in effect. But in those 96-minute time steps between the frames, you can see a little bit of movement as these 4 little moons go around Pluto and Charon. And that movement is what was the utterly definitive proof that we had discovered here, the 5th moon called Styx. There's a lot of processing that's gone into this image to reduce the glare from Pluto and Charon. For comparison, Styx is about 100,000th as bright as Pluto itself. So after all that processing, it leaves a kind of a mess in the middle, which is where Pluto and Charon are located. But in this version, the goal was just to see what else might be in the system. All right, if you go on to slide number 3, once we knew about Kerberos and Styx, the question was, well, where have they been hiding in the Hubble data all along, and we just overlooked them? And sure enough, when we went back in time through the archives of the telescope, we found a number of detections of both Kerberos and Styx going all the way back to 2005. This is actually not unusual in astronomy that you have what are called pre-discovery detections of an object. The reason being is that it's much easier to find an object if you know where to look. What's I think interesting about Figure 3 here is that this is actually the discovery of Hydra. So my colleagues on the New Horizons team who discovered Hydra, if they had only known to look much, much deeper into this system, they might have actually seen Kerberos a whole lot earlier. But, of course, in retrospect, we knew exactly where to look, and it was at precisely the right location. All right. So our plan originally had been just to study the orbits of Kerberos and Styx, these newly discovered objects. But as we dug deeper into the Pluto system, it just became a more and more bizarre story to tell, and that's what we're talking about today. If you move on to slide number 4, you can see a little animation of what we expected the system to look like if it had just had 1 moon. You have Pluto and Charon going around one another in the middle, and I've drawn in this little cartoon of a red elongated moon. Let's call it Nix just to be specific. The moons in the solar system are almost always in what's called synchronous lock. What that means is that they keep one face pointed toward the central planet. This is the same, of course, with our own moon, where we on Earth only ever see one face of the moon. Well, also, in fact, for small moons like Nix and Hydra and so on, we often expect them to be irregular in shape. They're not big enough to sort of crush themselves down into spheres. So when that happens, you always expect the long axis to be pointed toward the center. So this little animation shows us what we're expecting to find. What we found, in fact, was quite a bit different from that. And let's continue on to slide number 5. And this is just a little 2-frame animation to sort of get across the idea of the kind of measurements we were making. So now I have shown Nix, this little red ellipsoid, at 8 different points in its orbit. If it were synchronously locked, it would be pointed toward the center. And what that means is that if you look at the 3 o'clock and the 9 o'clock position, that's the position in which we're seeing the full cross-section of the object, where it's a bit foreshortened at noon and at 6 o'clock. So we can't measure the shape of this object because it's just a dot in our best images right now. But we can measure how bright it is. And so if we assume that it's in synchronous lock, what we expect is that it will be much brighter at 3 o'clock and 9 o'clock than it is at noon or 6. And so that was the pattern we were looking for in the data. What we found in the next slide, figure 6, is very, very different from that. As we started to assemble the measurements of the brightness of this object, there was just no pattern whatsoever. Sometimes it was bright, sometimes it was dim, and it just didn't correlate in any conceivable way with where Nix was in its orbit. The same was also true of Hydra. Now we're not able to obtain good enough measurements of Kerberos and Styx to make the same kind of an analysis, but it would be our expectation that also that these are small irregular objects. And what this slide is showing very definitively is that Nix and Hydra are not in synchronous orbit, which makes them very, very unusual objects in the solar system. And we had to stop to think, now how could that possibly be? And as we thought about it a little further, we realized that, the key to the problem is that we are looking at moons orbiting two objects, a dumbbell, as I described earlier, instead of one. And so if you go to figure 7 and click on play, you will get a sense of what is the reality. This is the result of an actual numerical simulation. The folks at Space Telescope Institute did this beautiful job of making it look like a little cratered spheroid, which is probably close to what it is. But the motion is very much the real motion that we would expect for Nix. So imagine for a moment that you're sitting at the center of the Pluto system and you're watching Nix as it goes around you. So you're actually rotating as it goes around. That's why the star field in the background is doing what it's doing. And at first it wobbles a little bit, but depending on where you are in the video, maybe 30, 40 seconds in, it flips over. It is essentially an unpredictable situation. This is called chaos. This is a phenomenon that comes up in certain physical systems where they become fundamentally unpredictable. You can never really know enough about the orientation of Nix at any given time to really predict what it's going to do very far into the future. So if you can imagine what it would be like to live on this body, it's a very strange world. You would literally not know if the sun is coming up tomorrow. For that matter, the sun might rise in the west and set in the east. The sun might rise in the west and set in the north, for that matter. In fact, if you have real estate on the north pole of Nix, you might suddenly discover one day that you're on the south pole of Nix instead. This is the environment we're talking about for Nix and for Hydra, and we believe for the other moons as well, although we don't have the data to show that. I know this is a lot of fun to watch, but I think we have to move on to figure 8 now. With all the data that we've got, particularly all these measurements of brightness, we've been able to actually pull out the shapes and sizes and some information about the colors of these objects. And there's another interesting story to tell. Now, Nix and Hydra, we find, are actually fairly bright objects. They reflect about 40% of the sunlight that hits them. That would be comparable to kind of dirty snow or desert sand. We would definitely think of them as fairly bright objects. And in fact, in this way, they are very similar to Charon, the very large moon, which also reflects about 40% of the sunlight. Now, Styx is a little bit too small for us to say very, very much about how big it is or how bright it is. But the real shocker for us was when we figured out the properties of Kerberos, which, of course, orbits directly between Nix and Hydra, although not to this scale, of course. Kerberos has to be a very, very dark object. In fact, it can only probably reflect about 4% of the light that strikes it. So think of a charcoal briquette orbiting between two dirty snowballs. Now that's a very, very strange result. We certainly believe that all the moons of Pluto probably formed at the same time in one big impact event into the proto-Pluto object. And so if they all formed together, they all formed out of the same stuff, it's extremely hard to understand why one of them is a charcoal briquette and it's orbiting between two snowballs. So with that, I'm going to pass over the speaker's slot to my co-author, Doug Hamilton, who will tell the rest of the story.
Hey, thanks, Mark. So Mark has shown you results for how Charon, the dumbbell-shaped object at the center of this system, Pluto-Charon, how that affects the spins, and then a little bit about shapes of objects, and ending up with coloration. And so what I want to talk about next is if Charon can affect the spins so strongly, what might it do to the orbits? So if we go to the next figure, figure 9, it's a little animation here. So you have Pluto-Charon at the center, and the 4 moons, 4 small moons, in the colors, red, green, yellow, blue. And if these 4 objects were to rotate around or orbit around a single central Pluto, in the absence of Charon, they would follow the circular orbits, the solid circular orbits, which are dashed in the second bit of the frame there. And those orbits are nearly circular, very regular. And what happens next is if you put Charon in the system, the real system, the moons do not follow the circles anymore, or the near circular orbits. They follow sort of wobbly orbits, and you can see the shape there, distorting from the circles to the more distorted shapes. The moons orbit around the barycenter of the Pluto-Charon system with several week-long periods, 3 to 6 weeks, and Charon itself orbits in just 1 week. And so what you get is perturbations. Each time Charon passes by one of these moons, it pulls on it a little bit more strongly, and that gives sort of week-long oscillations on top of the longer periods that these 4 moons have. And so that tends to destabilize the system a little bit. So you can imagine if the orbits are circular or nearly circular and regular, they can kind of repeat what they're doing over and over again. But now when we have Charon going by every so often, pulling, changing the orbits slightly, the orbits move in less predictable ways, chaotic ways, and this reduces the stability of the system. The system would be most unstable if it ever lined up just as you see it here in this image. So in other words, if Charon and the 4 moons all lined up along the horizontal axis there on one side of the planet. The reason that's the most unstable is all the objects are as close together as they ever get, and so their gravitational forces upon one another are as strong as they ever get. And so the moons of Pluto, these small moons of Pluto, are packed pretty closely together. You can't really put additional objects between them and have those orbits be stable. And so the question is how the system can remain stable in its current configuration. So what we've discovered also, in addition to the spin results, we've discovered that there's a relationship between these three of these moons that prevents the moons from ever lining up as you see them here. So there's 3 objects, the red one, green one, and the blue one. These guys have a relationship between their orbital periods that prevents them from ever lining up along one axis. So if we go to the next slide, this should be an animation. It's not one for me, but I can describe how this will work. So this is the 3 moons that are related by the resonant relationship is Nix and Styx and Hydra, the green, red, and blue objects. So these 3, as you see here, they're lined up on opposite sides. Styx and Hydra on one side of the Pluto-Charon system, and Nix is on the opposite side. And so what this figure is showing is, if you imagine fixating on Nix, that's the little home icon there you see on Nix. If you imagine fixing that on the x-axis there, staying with Nix and watching the other 2 satellites as they orbit around Pluto-Charon, what happens is Styx will go around twice and then come back to the position you see it in now, and Hydra will go around in the same amount of time, will go around the center 3 times and return precisely to the location where it is. And so this is a regular system that repeats over and over again. So they start like this. If you run the movie, the Styx and Hydra will move relative to Nix, and they'll come back precisely to the same location. And in doing so, the key point is the Hydra and Styx, these 2 satellites, will line up at different locations around the clock face that Mark referred to earlier. Here they are lined up at 9 o'clock. They line up at several other locations as well, but they never line up with Nix. So they never line up at the 3 o'clock position with all 3 moons in a row there. And so what this relationship does, it's a resonance. This relationship prevents the 3 moons from ever getting close together all at the same time. And that helps to stabilize the system. So we do not know exactly how the system formed, and we know it's sort of maximally packed, has the most satellites close together, as you can imagine, and this is one way in which Pluto and Charon are able to do this. These three satellites know about each other's orbits, and they prevent themselves from ever coming close to one another all at once. This is called a three-body resonance. We know of one other example like this in the amongst satellites. And if you go to the next slide, these are more familiar satellites, Io, Europa, and Ganymede, and they do something very, very similar. So this plots very much in the spirit of the previous one. Your home here now is on Europa, and if you watch the inner moon, Io, it'll go around twice, return to the same position. Ganymede will go around once and return to its same position. And just like at Pluto, these satellites just repeat this over and over and over again, the same cycle. And again, just like at Pluto, there's never a time when all three of these satellites line up, all on the same side and in a straight line. And so just as at Pluto, this stabilizes or helps to stabilize the orbits by minimizing the strengths of the gravitational forces between the satellites. Okay, so we go on to the next slide. There's a second or another interesting analogy one can draw with the Jovian system. So this is a montage from Voyager 1, taken back in 1979. These are images all taken at separate times and then combined together to make a pretty view that shows you the four largest satellites. You know, a perspective looking over the limb of Callisto towards Jupiter and seeing the other moons in between Jupiter and Callisto. The interesting thing about Jupiter, you wouldn't think Jupiter would have much to do with Pluto. Jupiter is the largest planet in the solar system, and Pluto used to be the smallest planet in the solar system, and now it's a dwarf planet. But if we go to the next slide, what we've done here is replaced Jupiter with Pluto, an artist's conception of what the Pluto surface might look like, and we'll find this out very soon. And we've just relabeled the same Galilean satellites from the previous image. We've relabeled them with the four satellites of Pluto, and we've added Charon in as well. And the reason we've done this is to emphasize the point that these four satellites of Pluto, their sizes relative to Pluto, are very, very similar to the sizes of the Galilean satellites to Jupiter. So what Pluto is really a miniature Jupiter system. We've got Pluto taking the role of Jupiter, and the four Pluto satellites taking the role of Galilean satellites. The one difference, of course, is we have this huge moon Charon in the Pluto system, and we do not have an analogous large satellite like that at Jupiter. It's fun to think about what that might look like, and so we go to the final image, and so if Jupiter were more like the Pluto system, this is what it would look like. You'd have your four Galilean satellites and Jupiter, and then you'd have close into Jupiter a huge binary planet. You'd have something larger than Neptune, which orbits around Jupiter. And so if you think about this, it's perhaps not so surprising that the effects of this Neptune moving around Jupiter, you can imagine that's going to make all of our satellites not be able to orbit cleanly around with one face towards Jupiter. This is what happens at Pluto. The moons can't maintain that orientation. Each time Charon passes by, they get pulled, and the satellites just cannot rotate around a single axis. And in the same way, the orbits are perturbed, and this resonance that we found is one way in which those orbits are stabilized. So I think that's all I wanted to say, and so I want to pass the baton now to John Spencer, who will tell us a little about the New Horizons mission.
Thanks a lot, Doug. This is John Spencer. I'm a science team member on New Horizons, and Mark and Doug, with all these discoveries, have made my life pretty interesting in the last couple of years, because these discoveries of these additional moons have made significant changes to some of the New Horizons plans, as I'll describe. New Horizons, of course, will fly through the Pluto system on July 14th, 2015. Hard to believe that's only a month and a half away now. We'll get incredibly detailed pictures of Pluto and its big moon Charon, but we'll be also looking at all these small moons as well. We have to be patient. We'll get a few pictures down right in the middle of July when we fly past, but to get all the data down, including all the pictures of the small moons, will take up to a year. So we'll be learning a lot more gradually as we go along. But New Horizons will certainly revolutionize our knowledge of these moons, and will definitely prove Mark and Doug right, or possibly wrong. We'll find out when we get there about the sizes and shapes and behavior of these moons. We're very much looking forward to finding all this out. We've already seen all the 4 small moons that Mark and Doug were talking about. In fact, you can go to the New Horizons website and you can see images of these moons orbiting around Pluto as seen from New Horizons itself. Pictures are getting better every day. It's really an exciting time for us. So when we get closest to Pluto on July 14th, we'll be taking pictures of Nix and Hydra that will be 50 or 100 pixels across, maybe bigger, depending how bright they turn out to be. So we'll see a lot about their surfaces. We'll see if they have craters or fractures or anything like that. We'll get the composition of their surfaces. We'll also be, as Mark described, looking at the brightness variations over the months of approach to see how they're varying, and learn maybe a bit more about the rotation rates, these remarkable rotation rates, chaotic patterns that Mark talked about. We're already working on that, in fact. For Styx and Kerberos, they weren't even discovered when we made our initial plans for the Pluto system, so we deliberately left spaces in the plan for, we'll figure out later what to do at this particular time during the flyby. So when we learned about these discoveries, we added observations of these new moons to those gaps in the timeline. We won't get great pictures of Styx and Kerberos, but they'll certainly be good enough to see how big they are, how bright they are, some idea of their shapes, and that will certainly allow us to confirm Kerberos being this charcoal briquette between the icy, the brighter worlds of Nix and Hydra. If that is indeed the case, we will be able to confirm that. And we'll also be looking for new moons in the system. We are interested, of course, for a scientific point of view, because it will help complete our picture of how all these worlds are interacting with each other and how they may have formed in the first place. But we have a more mercenary interest because we're flying through this system at high speed. Finding these additional moons was a little bit of a wake-up call to the New Horizons project that there might be enough debris in the system that could cause a threat to the spacecraft as we flew through the system. Because even a particle the size of a grain of sand, if it hit the spacecraft at the speed that we're going, could cause damage if it hit the wrong place. So following this discovery, we've organized a program to look very hard at the possible danger, not from the moons directly, because the moons are small enough you're not going to run into them themselves, but they could be releasing debris that we could run into. So we've done a lot of work that Doug and Mark have helped with to see whether we do have a threat from these 4 known small moons. We don't think we do at this stage, but in case we do find evidence that there is debris that could be dangerous, or we find new moons that might produce dangerous debris, we've developed a set of contingency plans for the spacecraft so that we could increase the chances of survival should there be a problem like that. Right now, we do not expect that. But we're ready for anything at this point, and we're keeping a close eye on the system as we get closer. So that's the New Horizons perspective. I'll pass you on now to Heidi Hamill, who I think will provide a bigger picture perspective on what this all means.
Thanks very much, John. I really wanted to make 3 points about the results today. First of all, these are wonderful science results from Hubble, but there's no amazing picture or gorgeous image of Pluto and its moons here. There are many creative photo illustrations, but Hubble is in orbit around the Earth and is 300 billion miles away from the Pluto system. And the objects in the Pluto system, including Pluto and its large moon Charon, are relatively small objects on the cosmic scale. So with Hubble being here at Earth, we basically are only seeing these moons as points of light. Even Pluto itself is just barely resolvable by Hubble as a planetary disk. Even so, even seeing just points of light for these small moons, what you've heard today from the other speakers is that we're able to infer a lot of information, like their shapes, their sizes, their colors, their chaotic rotational states, and how they interact with one another. And so this is just another example of how powerful a machine of the Hubble Space Telescope truly is. Second, I want to echo what John Spencer was just saying. The New Horizons flyby is now just 6 weeks away. We're counting days now. I post on Facebook every day. 42 days left to the flyby. We can't even imagine the details we're going to see. We may find new moons, rings, who knows what. And all of this information is going to further help us understand the dynamics and history of this double dwarf system, Pluto and Charon. So I want to remind everyone to stay tuned for the New Horizons flyby on July 14th and to pace yourself for the year following that, because it's going to take, as John said, it's going to take a year to 16 months for all the Pluto system data to be trickling in from the edge of our solar system. So pace yourself. Third, as both Mark Showalter and Doug Hamilton said, the Pluto-Charon system is a double planet system, a double dwarf system. And Doug showed how the Pluto system can scale up to be Jupiter-sized, but Charon would add an extra Neptune in there, so the Jupiter-Neptune system, which we don't have in our solar system. But I want you to imagine now scaling up even further, and instead of talking about planets, I want you to think about this as star systems. What if Pluto was the size of our sun? And then Charon would be a small star, and it would be a double star system. And we actually know from many of our telescopic searches that double stars are ubiquitous throughout our galaxy. And thanks to NASA's Kepler spacecraft and many other telescopic searches, we know that many of these double stars do host planets. So Pluto and its complex and chaotic moon system can provide a direct analog for these planetary systems we see around other stars. So let me just tell you a little bit about these planets, or since they're orbiting other stars, we sometimes call them exoplanets, and how Pluto's results today can help us understand these. A star that circles a planet that circles a binary star is called a circumbinary planet. And perhaps the most famous circumbinary planet is not actually a real planet, but rather a movie planet, the planet Tatooine in Star Wars, the planet where the young Luke Skywalker encountered Obi-Wan Kenobi and began his journey to become a Jedi Knight. Even though that's a fictional circumbinary planet, we now know of, last I checked, at least 17 circumbinary planets. And several of those planets are, in fact, in circumbinary systems. In other words, more than one planet revolving around a binary star. Now, I wanted to remind you that everything we learned today about the moons of Pluto, everything we're talking about, their masses, their rotations, their interactions, we actually learned without resolving these moons. They're just points of light. And what we are developing now in astronomy are the capabilities of seeing other planets around other stars as points of light, separating from the host stars. A new instrument called the Gemini Planet Imager on the Gemini telescope is making measurements of exoplanet brightnesses distinct from their host stars. So thanks to this very interesting work on Pluto, we will someday be able to apply the same kinds of tools and techniques that you heard about for Pluto's moons and apply those tools and techniques to study exoplanetary systems around other stars and learn about the capability, about the characteristics of those planets in that kind of detail that you're hearing about today. And all of this is grounded in our knowledge of these 4 tiny moons traveling in their chaotic orbits and chaotic rotational states around the distant binary Pluto and Charon, as seen with the Hubble Space Telescope. Alicia, back to you.
Thanks, Heidi. With that, we'll start the question and answer session. We have several reporters on the telephone bridge today, and we'll need to limit everyone to one question and one follow-up. Once everyone has had a chance to ask a question, and if time permits, we'll start from the beginning again. For those dialing in, please push the *1 key on your telephone to be placed in the queue for questions. For those who would like to ask questions using Twitter, please send your questions to #AskNASA. Our operator should identify you, but if not, please identify yourself, your media affiliation, and then direct your question to a specific panelist if possible. We will wait a few seconds for folks to get ready. Okay, operator, can we have the first caller, please?
Our first question is from Peter King with CBS News. Your line is open.
Great, thank you, and good afternoon. Congratulations on the discovery. I guess this message, or the question is for either Doug or John. This seems so unusual. Have you ever, or have scientists or astronomers ever seen anything quite like this before in terms of the chaos, in terms of the odd shapes of these moons and so on and so forth?
Yeah, this is Mark. I think I can take that. There are similar, there are occasional pockets of similarity in the solar system. For example, we reported the very strange result that Kerberos is a very dark object compared to its neighbors. There is actually one tiny little moon of Saturn called Aegeon that is reflects only maybe 10 or 15% of the sunlight that strikes it, and it's just next to the much brighter other moons of Saturn, which are almost like snowballs in that they're very, very reflective. We also see signs of chaos in the Uranus system, where there are a number of moons that are orbiting in fairly close orbits, and it becomes very difficult to add another moon to that system without the whole thing going unstable. So we see places where things like this are happening. And by the way, the irregular shapes is a very common trait of most small moons. When they're too small to have the gravity sort of crush, their self-gravity crush them down into spheres, they end up being irregular in shape like this.
Okay, thank you. Next question, please.
It comes from Seth Bornstein with the Associated Press. Your line is open.
Yes, thank you. I do have one question for John Spencer and then a follow-up. For John Spencer, forgive me if I missed this. Is there any point during New Horizons mission that it will be in a place where you can get all 6 objects in one image? Or what is the most you, given where you know, what you see in terms of the path, how many objects can you get in one image?
Well, in fact, the best time to do that is now on approach, because the system is still quite small, and so it's covering a fairly small patch of sky, and even with our highest resolution narrow angle camera, they will all fit in one image. And in fact, on the New Horizons website, we've released a couple of images that do show all the moons, though they look a bit like the Hubble images that Mark Showalter showed. The problem being that Styx is 100,000 times fainter than Pluto, so in order to see Styx and Kerberos as well, which is also quite faint, simultaneously with Pluto and Charon, you have to do a lot to reduce the brightness of Pluto and Charon, and they end up looking like these rather ugly blobs in the middle. So we don't have a really pretty picture at this point of all 6 objects, but we certainly have pictures of them all already released, and we'll be getting more. And maybe we'll try and make something prettier as we get closer.
And this is for the other John Grunsold, if you're still on there. Given this, what we're learning more about the Pluto system, I mean, I don't mean to bring back a 9-year-old debate, but does this provide even more evidence that the IAU is right in demoting Pluto, this type of chaotic system?
I'm sorry, you only get one question, so I won't answer that. No, just kidding. I'm just kidding. Actually, to me, it's not a very interesting question, what we call Pluto. Clearly, we're looking at a new class of object that we've never investigated before in this whole system. And I think, between, all the discussion you've heard, that we're calling Pluto and Charon a double dwarf planet, but it's really, a whole system of objects. I mean, and Heidi likened it, Heidi Hamel, used the analogy of it's kind of like looking at a double star system with the planetary bodies around it. I think what's really interesting is that we are entering this new realm of the solar system. And Pluto New Horizons is not going to stop and loiter and look. I mean, it goes flying right through, and it will continue to traverse into the Kuiper Belt. And Hubble has also already found a few objects that it might, at least one of which it might be able to visit in the future, that may give us even more information about this new class of objects. And so, what we call things is, is important to have the language to be able to discuss them. To me, it's just not that interesting a question of whether, we call something a dwarf planet or a planet.
Thank you.
I would add that dwarf is an honorific. It's like saying Sir Pluto. It's a dwarf planet.
Okay, thank you. Next question.
Comes from Irene Klotz with the Discovery Channel. Your line is open.
Thanks very much. I have a couple questions. First, I just wanted to clarify that the binary nature of Pluto and Charon was known previously. That is not part of what's new about this research. Is that correct?
That's correct, yes.
Thanks. And then secondly, as far as the darkness of Kerberos, is there? I realize there's not data for this, but you guys have good imaginations, and there's some oddities like Apatis and some other moons that seem to show unusual colorings and have something to do with the relationship between their sibling moons. What's your best guess as to why that is so different in brightness?
Well, I'll put in this is just wild speculation that needs a whole lot more work. But one of the things we do know about the Pluto system is that much as the Earth and Moon system formed in a big impact, the Pluto system did as well. And I think a lot of us believe that so this one impact created a big debris cloud, and Charon formed out of the innermost part of that debris, and with some details still to be filled in, the other moons are probably leftovers from that debris cloud. Well, you could imagine there are some very, very dark objects out in the Kuiper Belt that are literally as dark as this as 4% albedo, the reflectivity of Kerberos. If you imagine that the impactor that plowed into Pluto was a very dark object, Pluto itself is a much brighter object, that you would end up with this heterogeneous cloud where there's some dark material mixed in with the bright material, and maybe Kerberos is just a chip off of the impactor rather than a chip off of Pluto. As I said, that's speculation. There could be many other explanations for it, but at least it's one of the ideas that we're tossing around.
Thanks. And the last question is maybe for Doug, since you talked about the resonance of the Nix and Hydra and yes. So is your thinking, if your computer models show that it is now as fully packed as it could be to still have these bodies in the system, is the thinking that there used to be a lot more and they got scattered, leaving kind of maximally packed at this point, or is there some other story about how these all came to be in their present orbits?
Yeah, that's a good question. So let me just start by saying that you can put more moons in the system. So you can put moons to the outside of the outermost moon, Hydra. And if you put them far enough out, just spaced roughly evenly as the current ones are, you can add more moons in that way. And there are other little dynamical niches where you can safely add moons as well. It's just hard to put them between the orbits of the current moons. There probably were more moons in the past, in the sense that the scenario we believe most is that the Pluto-Charon binary formed with a large impact, as Mark was just saying. And so you have a large impactor that strikes a previous Pluto, and you produce the moon Charon and some debris, and the debris then collides amongst itself and settles down ultimately into the 4 moons that we see today. So there was a time when there were 5 moons, and then there was one more collision to make 4. And so that tends to be what happens. You tend to have moons in a region of space, and if you wait long enough, they will the ones that are too close together will collide and merge, and then eventually you're left with the ones that are, that are far enough apart that they can remain stable. So yes, probably there were more moons in the past.
Thanks. Okay, thank you. Just a reminder, just due to time, we'd like to limit all questions, all reporters to just one question, and then if we have time, we'll have follow-up questions. So, operator, can we have the next caller, please?
It comes from Keith Cowing with NASAWatch.com. Your line is open.
I have a question I'm going to pose chaotically about the chaos you're seeing. You mentioned the similarities between this system and the Jovian system, and I would assume the Saturn system as well, where you have moons and strange embraces and resonances. But in both cases, like with Europa and Io and Enceladus and Ganymede, apparently these interactions cause heating of the interior, oceans, and stuff like that. In a system like this, where you have Charon and Pluto in a locked embrace, are you expecting to be able to see deformations where you might have sort of like a standing wave within which you might have some liquids? And also because of the chaos of these other moons going around and the fact that there's a lot of water in this equation, are you expecting to be able to see some hydrostatic alterations in the surface of these moons as well? Is that how you're going to figure out what's inside of them, given you're flying through so fast?
I guess maybe I can take that one, or at least take a start at it. One difference between the Pluto-Charon system and some of these other systems that you mentioned is that Pluto and Charon are completely rigidly tidally locked to each other. They always have the same face facing each other. So the gravity that each one feels from the other, despite the chaos of the small moons going around, is pretty static. And so in a simple interpretation, we don't expect a lot of tidal heating of Pluto or Charon as a result of them being so close and in this locked situation with each other. The other moons will certainly be feeling stresses, and because the gravity on them, it's kind of the opposite situation. It's rather than being completely fixed, it's changing all the time. Probably these moons are too small that even if heat is being generated, as it probably is, they're probably not going to retain enough of that heat that you would get melting and liquid water. But we'll certainly be on the lookout for that kind of thing. We'll be looking at the surface composition with New Horizons as we fly past, and maybe we'll see evidence for water alteration. I'd certainly love to be proved wrong about the unlikelihood of any kind of liquid on these worlds. So right now I wouldn't bet on seeing evidence for liquid.
This is Heidi. I just wanted to follow up on that. I'm glad that John used the word probably, because if we learned anything from our spacecraft encounters, it's that these systems have a tendency to surprise us in remarkable ways. So while I wouldn't bet the farm either, John, I don't know what we're going to see, and it could be very interesting. We certainly know Pluto has a lot of dynamic activity in its atmosphere, and that might be related to the surface. It's going to be great to see.
Yes, I will just qualify what I said, that it's quite likely we will see activity on Pluto, but it probably isn't driven by tides the way that activity on Enceladus or Europa or Io is driven. But yeah, we'll see soon enough. It's going to be amazing.
Okay, thank you. Next caller, please.
Our next question is from Bill Harwood with CBS News. Your line is open.
Hey, thanks, and I will help shorten the time by saying Irene Klotz asked my question and it got answered, so I'll pass. Thanks.
Our next question then is from David Perlman with the San Francisco Chronicle. Your line is open.
Okay, thank you. For Mark Showalter, about that debris cloud that might have been, or that you believe has been impacting the Pluto-Charon orbit. is there going to be any evidence of that debris in the form of either tinier moons or something else that might lead you to confirm that idea of the big impact?
That's a good question. I think the issue here is one of timescales. It's whatever did happen to create the Pluto system that we see today probably happened 4 or so billion years ago. And that's particularly with a lot of chaotic interactions going around and with all the other phenomena. The system's been cleaned out pretty well. So what we have left here is pretty stable, and there's probably not going to be, for example, don't think a lot of debris floating around unless it's coming off of, say, one of these moons and creating a faint dust ring. And that's, of course, something we're looking for very closely, particularly as it might relate to any hazards to the spacecraft. Now, if there's any leftover evidence of that debris cloud, say, on the surfaces of Pluto and Charon, I guess the only issue would be Charon's probably a heavily cratered object, which with its surface turned over many times. Pluto has an atmosphere and weather and things like that that probably mean that most of the direct evidence for the impact is probably gone by now.
Thanks a lot for that. And as a follow-up, what about the possibility that since New Horizons is going on into the Kuiper Belt, can it encounter any other objects on its trajectory as you guys figure it?
I can take that. We have a couple of objects that we found with Hubble thanks to tremendous support from the Hubble Space Telescope last year that we can actually reach with the fuel we have available on the spacecraft. We can't go to both of them. We have to choose one or the other. We will decide between those and set a course to one or the other late this year. But we will not be sure that we will actually have those flybys until our proposal to extend the mission and secure the necessary funding has been approved by NASA. So it's all provisional at the moment. But
do they have names? These other objects?
No, they just have numbers at the moment, which even I can't quite remember yet. But we will certainly be setting a course towards one or the other of them, and those encounters will occur in late 2018 or early 2019. And we'll also be flying pretty close to other objects that we found while looking for the ones we could reach, and we'll be looking at those from a distance. And we'll have a pretty rich mission to the Kuiper Belt after the Pluto flyby if the mission is approved, and that will be a matter for 2016.
Okay, thanks.
Okay, next caller, please.
Next caller is from Miriam Kramer with Mashable. One moment. Your line is open.
Hi, thanks so much for taking my question. I just have a quick question, I think, for Mark. And I'm just wondering, I'm sorry if you mentioned this before, but is Kerberos also locked in that resonant orbit around Pluto and Charon? Thank you.
No, Kerberos is actually not a part of it. It's the other 3 bodies in the system.
Okay, great. Thank you. Next question.
It's from Kelly Beatty with Sky and Telescope magazine. Your line is open.
Thank you very much. A lot of great stuff here. This is for Doug Hamilton. Concerning the resonances, the 3-4-5, the confirmation of the 3-4-5-6 arrangement, looking at the table in Nature, it looks like it's close but not exactly those integer numbers. Is there any significance to that? Is being off a little affect how you interpret it?
That's a great question, Kelly. So, we've noticed for a long time that the moons are very close to being in, a 3 to 4 to 5 to 6 relationship. But the data from this looking at all of the Hubble images, for the past 10 years, almost 10 years, is enough to say that they're not. They're actually not precisely 3 to 1 and 4 to 1 and 5 to 1 and 6 to 1. So those relationships are only approximate, and you see that in the sort of even spacing of the graphic that shows the locations of the orbits. And so what we have instead is sort of a replacement. Is there's a more exact relationship between the inner object, the second object, and the fourth one. So Styx, Nix, and Hydra. And so that's technically called a three-body resonance, and it's a relationship between all three of those periods. But no pair of them are in simple integer ratios. And so it's a little bit unusual.
Okay, next question.
Next question's from Mike Wall with Space.com. Your line is open.
Great, thank you guys. This is all very interesting. Obviously, I've just got a question for John Spencer, and that is, what, if anything, do these new results tell you about this hazard search, or like the ongoing new moons, like kind of hunt that you're doing for New Horizons? Do these new results make it seem more likely that you'll find any new moons or rings, or like do they make it less likely, or they don't kind of affect it at all? What are your sort of takeaways on that issue?
Well, I think thanks to the work that Doug and Mark have done, we now do have a better understanding of the dynamics of the system. And as people have said, it means the system is quite full. It's hard to just put additional moons in there in random locations because they probably wouldn't be stable. They would be thrown out, and there's a limited number of additional places that you could put moons, most of which tend not to be very close to where the spacecraft is flying through the system. So that's one of the reasons that at this point we think it's unlikely that we will have a problem with a hazard to the spacecraft. And we'll be looking for moons in unexpected places as well as expected places. But right now, the dynamics of the system make it likely that we probably won't have moons that are close enough to the spacecraft to cause us a problem. So yeah, it's been very helpful as part of this process and helps us breathe a little easier. But we're still obviously not being complacent, and we're looking for anything we might find, whether we expect it or not.
Okay, thank you. Next question, please.
Comes from Leonidas Papadopoulos. Your line is open.
Thank you very much. Good afternoon, and it's a very interesting conference. I would like to make a question about a follow-up about the hazard from the debris in the Pluto system. With 1 month and a half before the close encounter in July, how many days does the New Horizons team have available for finding something hazardous and averting the spacecraft away? And the second part of my question, is the debris hazard only important just before the flyby, or after the flyby the spacecraft can be endangered from any debris going the opposite direction? Thank you very much.
Okay, I guess I will take that. We have a whole series of observations that we're currently in the middle of as we approach searching the system for new moons or debris rings. And starting next week, we will have a chance to divert the spacecraft if we saw anything scary. And then we'll have a series of chances going in. The last time we could divert the spacecraft to a different trajectory based on what we might see on these approach images would be 14 days before closest approach. So more or less on July the 1st. And we'll be taking images up until that time, so we'll have the best possible information in which to make that decision. After that point, we have one more set of observations that we'll be taking specifically to look for hazards. And at that point, we'll be too close to divert the spacecraft, but we would be able to change the spacecraft orientation so that during the close approach period, we have our main antenna, which is this pretty robust dish that we could face forward that would give us protection from debris. We would use that as a shield going through the system. If at that point we thought there was a concern. If we don't want to do that willy-nilly because it would reduce the amount of science that we could gather during the close approach. So we would only consider that if we really thought there was a significant chance of some danger. To answer your other question, the period where there might be a threat is really just 2 or 3 hours around closest approach. That's when we're flying at our closest to all these moons that have been discovered. And it doesn't matter too much which direction the moons are going. There is a period of an hour or two beforehand and an hour or two afterwards when there might be a concern, with the biggest concern being right around closest approach. We will be hearing back from the spacecraft a few hours after the flyby on the evening of July 14th, and it will simply send a signal back at that point to say that it has made it through the system. We'll all be looking forward to that confirmation that everything went smoothly with great anticipation.
Okay, thank you.
That's great. Thank you.
Okay, we're going to take 2 more questions from the folks on the line, and then we will take 2 social media questions. Can we have the next caller, please?
It's from Frank Mooring with Aviation Week. Your line is open.
Thank you. This one is for John Spencer, and you may have answered it for Mike Wall, but I'm a little bit confused because you're flying into a chaotic system where things aren't completely predictable, yet you seem fairly confident that you're going to come through okay. Is there some overarching factor that's giving you that confidence? Is there something about the system and the way it behaves and what you've observed that makes you pretty sure you're not going to run into trouble? Thank you.
Sure. There's a lot of chaos in the system, as Doug and Mark have talked about, but there are parts of the system where things are pretty well behaved and predictable, and in particular, the big moon Charon is sweeping around Pluto in a very predictable regular orbit every 6 days, and it is very effective at clearing stuff out of anywhere near its own orbit. In a matter of days, if you had a big cloud of debris somehow introduced into that region, it would be cleared out in days or weeks. And that is the part of the system that we're flying through. We fly interior to the orbits of these outer moons, but right in the orbit of Charon, though Charon will actually be on the other side of Pluto when we fly past. And so Charon is going to do a lot of the work for us, despite whatever craziness is happening in the outer part of the system. Charon is clearing out that region. And also the other moons, though their orbits have these chaos aspects, they're still reasonably predictable. The moons are showing up exactly where we expect them to be in the New Horizons images as we approach. And as Mark was showing, he was able to go all the way back to images in 2005 and find the moons exactly where they were expected to be. So these chaoses in the orbits are fairly subtle, and it's not like suddenly Nix is going to be in a completely unexpected place and right in our face with the spacecraft or anything like that.
Thank you.
Okay, thanks. Next caller, please.
It is from Leo Enright with Irish Television. Your line is open.
Thanks for fitting me in, Felicia. This Nix movie, it kind of looks like an Easter egg rolling across the White House lawn. So I'm guessing when we show this, somebody's going to say, oh, come on, you're kidding me. I'm just wondering, is this the only explanation for your light curves, or are there other more prosaic possible explanations? And I'm also wondering, if I may, from John Spencer, whether there's any possibility of some sort of a cool movie showing this mojo, or are you just not going to be able to do that on your fly-through?
Yeah, it's Mark. I think I'll take at least the first part of that question. Now, I guess maybe I need to make it very clear. This is very sped up motion that you're seeing in this video. It is essentially one rotation around Pluto takes 2 seconds, where in reality it takes about 25 days. But no, we're not kidding. To be honest about it, this is a perfectly plausible. This is a mathematically, tested solution for what Nix might be doing. Now, there are times, because it's a chaotic system, you can't really predict it, and there are times when it does settle down into a kind of just a wobble for a while. So it doesn't necessarily show all this tumbling behavior all the time. But in fact, in our data, we see very strong evidence during the period, particularly from 2010 to 2012, that the pole of Nix was tilting, that it is not oriented the same way over this 3-year period. So that's a pretty good piece of solid evidence that this is not doing anything typical about its rotation, and that in fact its pole is changing at a rate that we can observe and measure.
And to answer the second part of the question, we certainly won't produce any movies that are quite as cool as that simulation in terms of seeing the continuous motion, but we will be imaging each of these moons quite a few times from different angles as we go through the system. And as I said, we're already observing their brightness variations as we approach. So we'll definitely be able to confirm that this chaotic rotation is happening and understand it better in terms of the specifics of exactly how it's rotating at any given time. And I'm sure we'll make some interesting releases and maybe some movies from them, but they won't look quite as smooth and pretty as the one that Mark showed.
Thank you.
And John, could I just add, John, do you plan to continue doing Hubble observations as well so that you will actually have Hubble data to tie to the New Horizons flyby?
Absolutely. There is a large campaign underway at the moment of Hubble observations looking at the Pluto system before and after the New Horizons flyby and during the flyby as well, and getting that kind of complementary data. So there will be interesting results from that too, I'm sure.
Thank you. Okay, so we're going to proceed to the social media questions. I've got two that I've kind of combined into one and an additional one. So the first question from Jason Major, are there any data on Pluto's moon's masses and densities? And related to that from John Ratnasne, do we have any idea of their composition?
So the question about their masses actually comes from work that some of our colleagues have done. You can't actually look at an object and measure its mass. You can only measure its mass by seeing its effects on other objects nearby. So work that was done with one of my colleagues, Marina Brozovic at JPL in California. Actually, Simon Porter has done some other analysis as well. We can basically determine the mass of Kerberos, Nix, and Hydra just because of the way they tug on one another. And in fact, the reason the Kerberos has to be so dark is that what we find is that it is about 1/3 as massive as Hydra, but yet it only reflects about 5% as much sunlight. And the only way you can make those two pieces of information work together is if it is extremely dark.
Okay. The next question we have is from Steph. How does this new knowledge about Pluto's moons impact NASA's future program and project?
Well, this is John Grunsfeld. These results are really exciting. They're very much a science story, and of course they're going to affect our Pluto New Horizons fly-through. But even beyond that, we'll continue to be able to observe this double planetary system with the Hubble Space Telescope, if the team proposes to use Hubble to continue to observe it, and especially with the James Webb Space Telescope. Pluto New Horizons will be long past Pluto by October 2018 when we launch the James Webb Space Telescope. But especially because it's an infrared telescope, it'll be very well suited to study this very distant system.
Okay, thank you. And that's all the time we have left for today's News Telecon. I'd like to thank the panelists and our operator for their time today. I'd like to ask the panelists to stay online for a few minutes for a post follow-up. If you've joined this telecon late, you can listen to it again by dialing 1-866-501-5087. That number again is 1-866-501-5087. And to find out more about these findings or for more information, please go to our website at www.nasa.gov or check out our many social media venues such as Facebook, Google+, Twitter, and YouTube. Thanks for joining us and have a great day.
That does conclude today's conference call. We thank you all for participating. You may now disconnect and have a great rest of your day. Stand by for post-conference.